The Kardashev scale is a method of measuring a civilization's level of technological advancement based on the amount of energy it is capable of harnessing and using. It was first proposed in the mid-20th century by Soviet astronomer Nikolai Kardashev, who envisioned a framework for understanding the development of intelligent civilizations on a cosmic scale. Rather than measuring progress by political structures, cultural achievements, or military power, Kardashev focused on energy consumption, which he believed offered a universal benchmark that could be applied to any civilization, whether human or alien. The central idea behind the Kardashev scale is that a civilization's ability to manipulate and consume energy reflects its capacity to exert control over its environment. The more energy a society can harness and use efficiently, the more advanced it is presumed to be. Kardashev originally divided civilizations into three broad categories: planetary, stellar, and galactic, each representing a different level of energy control. These categories are commonly referred to as Type 1, Type 2, and Type 3 civilizations. A Type 1 civilization, according to Kardashev's model, is one that can harness and use all of the energy available on its home planet. This includes not only the energy derived from fossil fuels and renewable sources such as wind and solar, but also geothermal energy, ocean currents, and the planet's total atmospheric and hydrological systems. Such a civilization would have achieved complete control over its natural environment, able to manage weather, control earthquakes, and regulate ecosystems with precision. It would have eliminated energy scarcity, potentially ending poverty and resource-driven conflict. In human terms, reaching this level would mean fully exploiting the Earth's energy budget, estimated in the mid-20th century as being in the range of tens of petawatts. A Type 2 civilization is far more advanced. It is capable of harnessing the total energy output of its star, not just the energy that reaches its planet. In our case, this would mean capturing all the energy radiated by the Sun. To accomplish this, a Type 2 civilization might construct vast structures in space, such as a Dyson sphere or Dyson swarm, encircling the star and collecting its energy output directly. Such a society would have complete control over its solar system, including the ability to mine planets, redirect comets, and build megastructures on an astronomical scale. The engineering challenges involved in reaching this stage are immense, requiring materials and energy far beyond anything currently available to humanity. However, the rewards are equally immense: access to energy many orders of magnitude greater than anything available at the planetary level. A Type 3 civilization takes this progression to its ultimate conclusion. It is able to harness the energy of an entire galaxy. This includes not only the energy from billions of stars, but also the rotational energy of galactic structures, the gravitational potential of black holes, and possibly even dark matter and dark energy if such forms of energy can be utilized. A Type 3 civilization would likely be capable of traveling between star systems at will, altering the structure of galaxies, and potentially even manipulating the fabric of space-time. It would be effectively godlike in its capabilities, at least from our current perspective. Such a civilization might appear indistinguishable from nature itself, having reshaped its surroundings so thoroughly that its presence is difficult to detect. Although Kardashev originally envisioned only three types, later thinkers expanded the scale to include intermediate levels and beyond. Some theorists introduced fractional types, suggesting that a civilization could be described as Type 0.5 or Type 1.2, depending on its precise energy consumption. Others proposed Type 4 and Type 5 civilizations, capable of manipulating the energy of multiple galaxies or even the entire universe. These extensions, while speculative, help frame the broader question of what is physically possible within the laws of nature and what ultimate limits might exist for intelligence and technology. Humanity, as it stands today, is not yet even a Type 1 civilization. Estimates place us somewhere around Type 0.7 on the Kardashev scale. We are still largely dependent on fossil fuels, and while renewable energy is growing, it represents only a small portion of our total consumption. Our ability to manage natural systems is rudimentary, and we remain vulnerable to natural disasters, climate change, and ecological collapse. Achieving Type 1 status would require a transformation of our global infrastructure, economy, and values. It would involve not only technological innovation but also political coordination and cultural adaptation on a scale never before seen. the transition to a higher Kardashev level is not just a matter of increasing energy output. It also involves changes in energy efficiency, sustainability, and ethical use. A society that generates vast amounts of energy while destroying its environment or enslaving its population would not be considered truly advanced. Many thinkers argue that a civilization must also evolve in moral and social terms in order to manage its growing power responsibly. This raises the question of whether technological advancement naturally leads to ethical maturity, or whether the opposite might occur. The Kardashev scale has also influenced the search for extraterrestrial intelligence. If intelligent life exists elsewhere in the universe, and if it has developed for longer than humanity has existed, then it is reasonable to expect that some civilizations may have reached Type 2 or even Type 3 status. Such civilizations might be detectable through their energy signatures. A Dyson sphere, for example, would absorb visible light from its star and re-radiate the energy as infrared heat, creating a distinctive spectral fingerprint. Astronomers have searched for such signatures using data from space telescopes, although no conclusive evidence has yet been found. This absence of detection is part of the broader Fermi paradox, which asks why we have not encountered signs of alien life despite the vastness of the universe. Some interpretations suggest that the transition to higher Kardashev types may be more difficult or dangerous than it appears. Civilizations may destroy themselves through warfare, ecological collapse, or technological missteps before reaching planetary or stellar mastery. Alternatively, advanced civilizations might become so efficient or self-contained that they leave few detectable traces. They may retreat into virtual realities, live in megastructures that are perfectly energy balanced, or operate on principles entirely beyond our current understanding. Critics of the Kardashev scale argue that it is overly simplistic. Energy consumption, they note, may not be the best or only measure of advancement. A truly advanced civilization might use less energy rather than more, having perfected efficiency and eliminated waste. Such a society might exist in harmony with its environment, using subtle technologies to achieve its goals with minimal disruption. Furthermore, the scale does not account for developments in biology, information theory, or consciousness. A civilization might be incredibly advanced in these domains while consuming relatively modest amounts of energy. Despite these critiques, the Kardashev scale remains a powerful tool for thinking about the future. It provides a cosmic perspective, helping to situate humanity within the broader arc of possible development. It challenges us to consider what lies ahead, what obstacles must be overcome, and what responsibilities come with greater power. It also invites philosophical reflection on the nature of intelligence, the meaning of progress, and the destiny of conscious beings in a vast and mysterious universe. Some futurists link the Kardashev scale to specific technological milestones. For example, achieving Type 1 status might involve global fusion energy, planetary climate engineering, and a unified planetary civilization. Type 2 might require interplanetary colonization, solar-scale construction projects, and artificial intelligence capable of managing complex systems at astronomical scales. Type 3 might involve interstellar travel, the engineering of entire star systems, and the manipulation of exotic forms of matter and energy. Others propose that the scale could be multidimensional, with different axes representing not just energy but also information processing, consciousness development, or ethical sophistication. This multidimensional approach would allow for a richer understanding of what it means to be advanced, recognizing that different civilizations may evolve along different paths depending on their environment, history, and priorities. In recent decades, the Kardashev scale has also inspired speculative fiction and popular science. Writers and thinkers have imagined what it would be like to live in a Type 2 civilization, with humans harvesting the power of the sun through space-based solar arrays, terraforming other planets, and coexisting with intelligent machines. Still more ambitious stories depict Type 3 civilizations building galactic networks, exploring parallel universes, or achieving forms of immortality and transcendence. These visions, while fictional, help explore the implications of real scientific ideas and offer a way to engage the public in thinking about the long-term future. Importantly, the Kardashev scale reminds us that humanity is still at the beginning of its journey. Our technological achievements are impressive, but they are dwarfed by what may be possible. The challenges we face, climate instability, energy transition, resource management, are not just problems to be solved. They are steps on a staircase that leads to a higher order of existence. Whether we ascend or fall depends on our choices, our vision, and our willingness to think beyond the immediate and the familiar. The scale also encourages humility. In contemplating civilizations capable of manipulating stars or galaxies, we are forced to reckon with the limits of our knowledge and the scale of the cosmos. We must admit that we do not yet understand the full range of what life and intelligence can become. This awareness can be sobering, but it can also be inspiring. It suggests that the future is not closed, that the boundaries of possibility have not been reached, and that the universe may hold more wonders than we can currently imagine.